Hello, my name's Adele Hudson and I'm from Aiken College. Today I'm going to talk about how we can develop application tasks in VCE Science. So if you'd like more resources, you can find these on MyChem Hub. It's good to kind of recap why is it that in VCE Science we're seeing many more questions in the end of year exam that are based around these application style questions. And that's good to go back and actually look at what the purpose of VCE is. VCE really is about providing equitable education, preparing students with skills for life, and really now in terms of many jobs, students are going to need higher order thinking skills. And there is a common understanding that these STEM skills are really important in a wide variety of careers. So if we actually look at the exams, I've actually done an analysis across all of the exams, so physics, biology, chemistry, environmental science, and psychology, and have really found across the board there is an increase in application style questions, in analysis style questions, and in also those questions requiring those key science skills. And in all of this, there is a need for students to show their ability to have scientific literacy and also an understanding of experimental design. They also need to be able to make connections between all the different areas of studies, the key knowledge descriptors, and also the key science skills. These are really challenging for students, and it's definitely where students are having to use their higher order thinking skills. So let's just recap on that. What exam skills are important? We've got the key science skills, and then we've got our higher order thinking skills, but still underpinning all of this, students are going to need those basic skills. And when I say basic skills, I'm not meaning easy. They're still going to need to know how to use formula, how to make unit conversions, how to write chemical equations. Now, they're not necessarily easy for students, but they are what I would consider the tools that those students will bring to the table when they're doing their application questions. If you look at across the board, all of the Science Examiner reports, there's some tips that you can pick up from that. And really across the board, every science is saying that our students can do better at application questions. Really, students at times, well often, they'll use generic answers. So they'll use them, say, from textbooks and they've learnt them, previous exams or commercially produced reference sheets. However, we need to emphasise to our students that every time they answer a question, they need to think about what the scenario is, what the context is, and then tailor their answer to meet that. There's other things that students can do as well, using a logical approach to answering questions. So actually giving the answer and then justifying it. Don't restate the stem in the question, and then also identify the intent of the question from the command terms. And then there is also the need to be able to spell key terms correctly. For our students in chemistry, it's good to be able to practice unit conversions, significant figures, applying and using formulas, and also the correct use of units. And then there's also the need to be able to interpret graphs, such as reading labels and titles in the legends. And then finally, it's those key science skills. How do you write conclusions? What's the difference between a systematic and random error? What about those terms? Accuracy, precision, validity, reliability, reproducibility, and also uncertainty. How are we able to combine all of this into what we do as teachers and how we actually embed this into our learning tasks? That's really what I'm looking for as a teacher myself. How can I make all the development of these skills inherent and explicit within what I'm teaching? When I look at application questions and the way that my students have answered them, across the class, I generally see a progression in their ability to answer those questions. You start off with a small minority of students who just cannot answer the question at all. And then there's a bigger range of students who actually, they know some facts. They're not necessarily relevant to the context and the scenarios, but they'll put them down anyway in hope that they'll hit the target somewhere. And then there's the students who they've got the right scenario, they've got the right context. However, they haven't got that ability to tailor it to that context by actually giving a tailored response. So what they do is they go back to what they've learnt by heart, by rote, and they will actually put that down as their answer. Then you have the students who are confident. They can actually give answers, and they can actually give examples and models and theories. However, there's the student who actually can then go beyond all of this. And what they're doing is they take that application question and then they think across the entire units 1 to 4, and they can see that they can draw knowledge from all of those different areas. And that's certainly a student who's well on top of their craft of understanding how to use their chemistry knowledge. So what I did was actually put together a progression rubric based on these ideas. And so you've got the base level where students can list their facts. The next level is where they can start to explain their ideas using some generic ideas. And the same where they can apply it, they know the context. But then you've got those students who can actually use some examples and they're really tailoring their answer. And then that final student who's elaborating on their ideas. And they've taken information from anywhere and everywhere across units 1 to 4. So in terms of different tasks that we can use, I'm just going to highlight 2 tasks that we've developed at Aiken in chemistry to help students kind of develop some of these skills. So the first one was actually their Unit 1 Area Study 3 research assignment. So in this assignment, we actually had a focus on actually teaching the students how to take notes. So actually reading information and summarising it down into something that is therefore transferable in their mind. So we actually got their final product was they actually had to represent all of their knowledge in an infographic. So this was their task outline. It said that their first thing they're going to do is actually use the Cornell note-taking method to summarise their ideas. And this was one that was actually developed at Cornell University in the 1950s. Now, the nice thing about this task is ideally, they're doing it in Unit 1, but ideally it's a skill that we can keep revisiting as they're going through Unit 2, and that'll give them a really good foundation for when they're in Unit 3 and 4. So if you actually look at the Cornell notes and the ideas behind them, they've got basically dividing it up into columns where on the side they've got like the questions that they're phrasing about their notes and keywords and then quick notes. And here, this is just like some instructions that we gave to the students, and basically it's just stepping out to the students what they need to do. And then this is an example of a student who was doing their research task on the Schrödinger model of the atom. So they were using both their textbook and then also articles beyond their textbook to actually find out more about these these two questions, an emission spectra and quantized energy. Now that was just a little excerpt that I took from their assignment. And then what they had to do was summarize all of that information in the end in a summary statement of just a few lines. So in terms of the assessment rubric, we've got again that column that I showed you before, how it's like an application of their knowledge and the progression of that. There's also the way that they use their language. Now, this might not seem challenging, but it is actually quite challenging for students to ensure that they're integrating that language in a way that's seamless, where it's not just a clunky definition. And then the last 2 aspects of this task was where they actually had to design graphics, so whether it would be flowcharts or graphs or even images, and they had to draw these and design them to then incorporate into an infographic. So the infographic was meant to identify all their ideas, show the connections between their ideas, and then also making links to concepts beyond the set topic. So really, hopefully, helping students embrace this idea of scientific literacy, that in order to know things well, we need to know more than just the basic dot points in the key knowledge descriptors. We actually need to have something which is like a real foundation and embedding it out. So this is a task that we've developed for Unit 4 Area Study 2, and it's basically where they're having to plan out an essay for an evidence-based argument about whether or not they agree or disagree with the claim that veganism and vegetarianism are better for a person's health and the environment than a regular diet that includes meat. And so then there's a few dot points that go through and specify what they're going to have to do in that. So in terms of how we develop these kind of tasks, really what I do is I search Science Daily, just sort of keep my eye on it and see whether or not there's relevant journal articles that are a starting point for a task. And this question actually did come from someone's research that they were looking at this. And what I do is I actually keep a bank of these articles and I share If I find things that are suitable for my friends who are teaching psychology or biology, I'll shoot them articles as well. And then what we do is we say, okay, we're wanting to identify the skills and the concepts that we're wanting to target in this task. And then we design the stimuli actually around this to prompt that connection of ideas. So in terms of what the students had to do in this particular part of the task, they had to do some recall, actually finding out what proteins are, where they find proteins, what about fats. Then they had to compare the two, compare a plant-based diet in terms of amino acids and also the saturated fats. And then they had to use flowcharts to actually show the metabolism of food in the digestion system. What about the role of enzymes and also including some chemical reactions? So you can see there's actually quite a few skills that are being touched upon, and we've got some basic, but again, not easy, but foundational skills in terms of writing chemical reactions. And then we're actually progressing up higher, where students are really having to connect, ideally, beyond even this part of Area Study 2, but even going back to understanding all the ideas around intermolecular bonding, which they learn in Unit 1, Area Study 1. So then the next part of the task is actually where students are looking at these key science skills, so accuracy, reproducibility, and repeatability. And again, this is a great way to integrate in to every task that we do, just some key science skills. The students are having to bring this up in their mind to understand again how these ideas are connected into the current theory that we're using. And then finally, this is a rubric that we use just across the board on top of the actual content knowledge. We're again wanting to see how well they actually can apply their knowledge and also how well they can use their terms. So just as a recap on what we did today, we were looking at why we have so many more application style questions in our end of unit exams, and why it is that these things are really valued for students. They can actually get those higher order thinking skills, and then some strategies that you can use to actually integrate these skills where students can learn them inside your course. Thank you.